All right, so today we are talking all about angles. So let's first start off naming angles. So I'm going to draw one. Here we go. B, C, D. Okay, there we go. Oh, let's throw a 3 in there. All right. So I can name this angle that I just drew technically 4 different ways. So we can name it using a labeled number with the vertex point, or by connecting 3 points starting at one of the rays, going towards the vertex, and then onto the other ray. So I could call this angle, let's start angle C, vertex. Or I could call it angle 3, labeled number. I could call this angle BCD, starting at B, going to the vertex C, and then ending at D. Or I could start at point D, then go to vertex C, then up to B. So I could also call this angle DCB. We can name that angle again all those different ways, but let's say that I have some ray segment cutting like that. And let's say I want to talk about this angle that I just labeled a 1. So we know that we can use labeled numbers, which we just have that 1 there. Fantastic. Angle 1. But let's say, let's label that an E. Using just the vertex, this is that trick, this trap that some people fall for. If I were to call this angle C, we don't necessarily know which angle we're talking about because we have 3 angles that meet up at C. So when you see something like this, you want to be more specific and use that 3-point method. So I would call this angle BCE or angle ECB. Again, though, having that vertex point there. Okay, so that's naming angles. That's what we got. All right, let's go ahead on to classifying. So if we were to classify based off of angle measure, we have 4 kinds. We have an acute, we have a right, we have an obtuse, and then we have a straight. Fantastic. So an acute angle is between 0 and 90 degrees. Right is exactly 90 degrees. Obtuse is between 90 and 180 degrees. And straight is exactly 180 degrees. An acute angle, again, looks teeny. It's a nice little one. Right looks exactly like an L. And you can tell that it's a right angle because there's going to be a square there. It's another way to think about it. Obtuse opens up a little bit more. And then straight, we have a straight line. Okay, so that's how we can classify them by angle measure. Wonderful. So the next little thing we have complementary angles and supplementary angles. So remember, complementary angles, these are angles that add up to 90 degrees. And then supplementary angles are angles that add to 180 degrees. So if I were to have this angle measure, let's say 57 degrees. If I wanted to find the complement of this, the complement would be 57 plus whatever gets me to 90, which in this case is 23. So the complement to this would be a 23-degree angle. And then if I were looking for the supplement, I do the exact same thing, but I just want to get whatever it is to 180. So 57 plus what? Gets me 180. And that is 123. So look at that mistake. Whoops. The complement is 33, not 23. My bad. 33. There we go. Complement is 33. That supplement is 123. All right. Oh, look at that. See? Mistake. Whoops. It's okay. It happens. Let's erase. You still there? I hope so. Okay. Let's get to angle addition. So if I have 2 technical adjacent angles, so let's say I have this angle here, boom. Angle A, B, C. Then I have this ray splitting it. Not splitting it, just in the middle. D is inside of it. What angle addition tells me is I can add the 2 smaller angles together and it will get me the entire angle. So if I start at one of the points on the outside ray, that's fine. A or C doesn't matter. I always just kind of like to start at the top. So I would say the measure of angle A, B, and then go up to D, getting angle 1 there, plus the measure of angle DBC, starting at D, back down to B, over to C, DBC, that gets me angle 2, is equal to the entire outside angle, the measure of angle ABC. And we can think that ABC, we could call it angle 3, just think it's 1 plus 2. So that's the formal angle addition postulate. Again, start at a point, go to the vertex, cut up, start in that middle part, back down to the vertex, back over. And then all around the outside, trace around the outside. All right, let's get some examples. So if I were to set up this example, I would start, I'm going to start at point S here. So I would say that the measure of angle STL plus the measure of angle LTU is equal to the measure of angle STU. So now taking the information that we know that STL is 38 degrees. Boom. We know that LTU is 65 degrees. Boom. And we're trying to find STU. So all we need to do is add 38 and 65, which is 103. So the measure of angle STU is 103 degrees. Again, do not forget those degrees. If you're solving for an angle measure, we're always working in degrees. All right, next one. So I am going to start at point B. So I have the measure, cut that, there we go. I have the measure of angle BCZ, plus the measure of angle ZCD is equal to the measure of angle BCD. Okay. BCZ is 33 degrees, got that, plus ZCD is what we're trying to find, so that's what we want, and then BCD is 91. So now, since we're given the whole and a piece, and we're trying to find the other piece, this is when you subtract. So 91 minus 33 is 58. So this angle measure is 58 degrees. Okay, there we go. So let's go ahead, keep on moving. So again, variables, don't panic. Don't freak out because you're seeing the x's. Geometry doesn't change. So I'm going to go FEW, so the measure of angle FEW, plus the measure of angle WED is equal to the measure of angle FED. So now, take it, plug it in. FEW is 4x minus 5. There we go. Plus WED is 40. Perfect. Is equal to FED 8x minus 1. There we go. All right, there's the geometry, algebra from here on out. Step 1, combine like terms. Boom, boom. 4x plus 35 is equal to 8x minus 1. X is to one side, so I'm going to subtract 4x. So I have 35 is 4x minus 1. Great. Add 1 to both sides. Love it. Get those constants on that other side. 4x equals 36. Last step, divide by 4. So I get that x is equal to 9. Love it. X is 9. But is that what this is asking me for? It's asking me for the measure of FEW, so I got to take that x, plug it on in. So we're given that the measure of FEW is 4x minus 5. Great. So take that 9, plug it in for x. 4 times 9, 36 minus 5, 31. So the measure of angle FEW is 31 degrees. Fantastic. All right, last thing we covered in this section, angle bisectors and congruent angles. So remember, an angle bisector, what happens is it is a segment, right, or line, splits an angle into 2 congruent angles. So if I have this diagram and I have that OC is bisecting angle AOB. Again, that means that angle AOC and COB are congruent to each other. So if AOC is 32 degrees, that means that COB is also 32 degrees. Congruent, done. If we're given that AOC is 27, and we want to find AOB, that's the entire thing. Well, since they're congruent, AOC and COB, both 27, So if I were to do 2 times 27 or 27 plus 27, gets me 54 degrees. Boom. Again, either 2 times 27 or 27 plus 27. Okay. Next one. So if I have AOB is 78 degrees. AOB is that entire angle. So the entire angle is 78 degrees. Since they are congruent, we know that that measure has to be split directly in half. So if I do 78 divided by 2, that gets me 39. That means that both COB and AOC's measure 39 degrees. Great. All right, last one. If BOC is equal to 4x and COA is equal to 36, 4x, 36, what do we know about congruent angles? Oh yeah, they're equal. 4x is equal to 36, since they're congruent. So x is equal to 9. There we go. X equals 9.